Hello, 8th grade. Today we're going to do equations with variables on both sides. Go ahead, update your table of contents. I'm going to be on page 14. Go ahead and pause this because I'm sure it's going to take you a while to write that. So I'm going to go ahead and go straight to page 14. So sometimes, yesterday we only had a variable on one side of our equation. Today what we're going to do is we're going to solve it when we have on both sides. So a few steps that we're going to do. Okay, so when you have an equation, let's do, give me 1 second. All right, my apology. I want to do, I don't have a good example. Give me 1 second. All right, so I have an equation. I'm going to put an example to the side, and we're going to do 4x is equal to 2x plus 2. Okay, now the steps in solving the first one. I don't have it in my example, but I want to make sure I put that there because sometimes you will see it, is the distributive property. And so we want to make sure that we take care of any parentheses or distributive property. So what does that look like? All right, if I had 2 times x plus 1, like I said, I'm going to do this example in just a minute. We would distribute this 2 to everything in the parentheses. And remember that there's no operation between this, so it's going to be multiplication. So 2 times x is 2x plus 2 times 1 is 2. Okay? Really, really important. Some of the problems that we'll have that, but not too many. You won't be tested on STAR for the distributive, but just giving you something that you will see in Algebra 1. All right, so number 2, which is where we'll start here, we are going to combine like terms. And you know what? I apologize. I was looking for a better problem and I did not get one. Let's pretend when you combine like terms, I'll get another one in just a minute. For example, all the constants, if you had a 2, -3, or -1/2, these are all like terms, okay? They're all constants, okay? Then you had maybe 2x, you have 5x, it could be negative, or just x by itself. These are a coefficient with the variable x. And then some other like terms might be, let's say 2y plus or 5y or -y. These are a coefficient with the variable y. Okay, so when we combine like terms, we always add and subtract either the number or the coefficient. When you have a variable that is all by itself, imagine a 1 in front of it. Okay, when you're adding and subtracting, you will utilize that 1. Okay? All right, so when we combine like terms, so for example, if I had 2x plus 5x plus 1 equals 3x. Okay? And I'm just using this as an example right here. I'm going to box from the back. So you want to put a different shape around each like term. So all my x's, and you always include the sign that is immediately to the left. Okay, sometimes we don't have a sign, and it's automatically, if it has no sign, it's going to be a positive. Okay. Now, if you notice, my other like term is a constant, but it's by itself. I can't combine that with anything else, okay? So when you combine like terms, you can only combine when you have two of the same on one side or the other. You cannot combine across the equation line. You can only combine on one side. So 5 and 2 is 7x. Okay? That is combining like terms. So for example, if I had another constant, I could combine that on the left. Okay? All right, step 3. You need to move the variables to one side. And step 4, which is kind of the same thing, you need to move constants to one side. Because remember, our whole goal is to isolate the variable to get the one x on one side because we want to find the value of x, and move the constants to one side. Okay? Let's look at what that means. So I want to go back to my original equation that I put at the top, although it did not have a combining like terms. I'm sorry I didn't have a better example. So let's go ahead and use that example. So 4x is equal to 2x plus 2. I'm going to circle my constants, and you know what, if you forget which shape goes to which, just keep the like terms with each shape. If I put squares around the constants, then put a circle around the ones with the coefficient and the variable. Okay? Do you have to do this? When you become fluent at this, you'll be able to solve it without even doing this, but until you get to that point, make sure you do this. So I have no terms for me to combine on each side because I have a circle, square, square. My goal is to move the variable to one side. So what I want to do, in other words, when I get my coefficient and a variable on one side and a constant on the other, I need to move this box over here. So how do I remove a positive 2x? You're going to subtract 2x, okay? So when you are moving variables to one side, you are adding and subtracting the coefficient or the constant, okay? So if you have 2 donuts and you subtract 2 donuts, you have no donuts left, do you? Okay, so that is a 0 pair. But if I subtracted 2x here, I need to subtract 2x here. Okay? So now I'm going to rewrite 4x minus 2. You're only adding and subtracting the coefficients, but do not separate that x from that coefficient. Think about it. If you had 4 donuts or 4 tickets or whatever your variable is standing for, 4 minus, and you spend 2, you're left with 2. So I no longer have any x's on my right, and my constant remains there. Now this is something that you've seen before. Yes? Okay. Now it's just continue to solve equation. Sorry about that. Continue to solve one step equation. So the only thing that we have learned new today is when you are combining like terms and you're trying to move the variable to the other side of the equation. We're going to do a couple of these as an example. So, and to finish this problem, yes, I would divide by 2 on both sides. Okay, I created a 1. I do not need to show that 1 is equal to 2 divided by 2 is 1. And that's my answer. Okay, so let's practice this on the graphic organizer that we did yesterday. Okay, and then I'm also going to give you a sheet. Your teacher will have it. Mr. Skinner will have it in the round building. Ms. Kowalski will have it in the rectangle. I want to do a couple of these with you, and I have maybe about 10 problems for you to practice a little bit more on your own. Okay? All right, so if you notice, I have a constant. I'm going to go ahead and circle that. I'm going to draw my line down, and I have a coefficient and a variable. If you notice, I have no parentheses, so now I'm down to step 2, which is combining like terms. So I look on my left. Do I have 2 of the same shape? I have 2 coefficients with the same variable, so I can combine those. Okay, and I like to add a word for the variable so it makes sense. If I have 2 pencils and Ms. Davison has 5 pencils, how many pencils do we have all together? That's right, we combine them. So we have 7 pencils together. All right, and I bring down my constant. Okay, and this is going to be a yucky number, yes. So we're at the point now where we're just going to divide. Divide by the coefficient in front of the variable. Okay, so I'm going to, 7 divided by 7 is 1. So x equals 10 divided by 7. Okay, all right, let's look at the next one. Again, I have a coefficient with a variable. So I have 2 on the right that I can combine. All right, this is a little tricky. What is negative 4 plus 12? Okay, if you put it in your calculator, it's the same thing as 12 minus 4, isn't it? So you have 8x equals negative 32. And this is something that we have already done. You divide by 8. You divide by the coefficient because you're trying to undo this multiplication. Okay? X is equal to negative 4. Remember that if you do not continue or keep any negatives, the answer is wrong. So they work long and hard to earn that little negative, so make sure you keep it there. Okay? All right. So a little bit different. Now we have a constant that we need to move. We only have one variable and coefficient. So now what I need to do, I can't combine these because they are on separate sides of the equation. So now I need to move this constant over to the other side. How do I move this? How do I undo subtraction? I add that constant. And if I do it on one side, I must do it on the other. Be really careful of your decimals. I didn't have enough room because I wanted to make sure I was showing you that I'm adding. So I created a 0 pair here. It adds up to 0, and I am left with 1, 4, and 4/10 x. And if I combine these, it would be 7 and 2/10. And it's natural human tendency to divide by the smaller number. It's sometimes because we want easy numbers. But remember, you're always going to divide by the coefficient in front of your x. And I can already see that this is going to be half, and so my x is equal to 1/2. Okay? And always box your answer. So I only have time for about one more. Same thing applies. You're going to box your x's, circle your constants, and I'm going to draw my line. I look at both sides. I only have one constant on my left. But if you notice, I can combine these, okay, because I have 2 of the same shape. I continue to add and subtract. 7 minus 3 is going to give you 4x is equal to 7. This is something that we've seen before. You divide by 4. Create your 1. X is equal to 7/4. Okay. Do the last one by yourself. You can pause it. I did have time for another one. So negative 2 plus 1 is negative x equals 9. We are down to the I cannot leave it like this. It must be divided. Remember, any x always has a 1 in front of it. Divide by negative 1. X equals, and I'm going fast because I'm fighting the time. It has to be under 15 minutes. Great job. This is really simple, but it takes practice. Okay, we'll see you tomorrow.